This image shows layering in a light-toned deposit in Melas Chasma. The layers are sedimentary in origin, but there are many processes that could have deposited them, such as volcanic airfall from explosive eruptions or dust-sized particles settling out of the atmosphere due to cyclic changes and deposition in standing bodies of water. By looking at the slopes in the layers and how the layers intersect each other, scientists can rule out various origins. A darker material can be seen covering much of the layer deposit. Some of this dark material is loose and can be seen accumulating as debris aprons at the base of steep slopes. Other dark material appears indurated and has been eroded by the wind to form etched edges with topographic expressions. The lack of impact craters on the layer deposit indicates that it is a relatively young deposit, or the craters have been removed by the wind, or the deposit was quickly buried and is now being exhumed. This channel on Mars was likely formed by large floods of water and debris that piled jumbles of rocks and sediment into mounds within the channel and created a long ridge downhill. The white stones visible in the center of the observation have captured the attention of curiosity scientists, because after driving over one of the rocks, scientists discovered pure sulfur crystals inside. The rocks don't appear to fit with other materials seen in this landscape. So it's possible that the stones were formed here, or they may have been brought by floodwaters or avalanches long ago, even coming from locations high above Curiosity, which was climbing the foothills of Mount Sharp. The yellow sulfur crystals found inside the rock mark the first time pure sulfur has ever been found on Mars. It isn't clear what relationship, if any, the elemental sulfur has to other sulfur-based minerals in the area. While people associate sulfur with the odor from rotten eggs, the result of hydrogen sulfide gas, elemental sulfur is odorless. It forms in only a narrow range of conditions that scientists didn't associate with the history of this location. The Curiosity Mars rover captured these feathery carbon dioxide clouds over an outcrop on Mars. The clouds, which are rare in the thin, dry atmosphere of the red planet, were much higher than is typical for Mars. Clouds are typically found at the planet's equator in the coldest time of year, when Mars is farthest from the Sun in its oval-shaped orbit. The fine, rippling structures of these clouds are easier to see with images from Curiosity's black and white navigation cameras. But it's the color images from the rover's mass camera that really shine. Viewed just after sunset, their ice crystals catch the fading light, causing them to appear to glow against the darkening sky. These twilight clouds, also known as noctilucent clouds, grow brighter as they fill with crystals, then darken after the sun's position in the sky drops below their altitude. This is just one useful clue scientists use to determine how high they are. This observation shows a tongue-shaped lobate flow feature along an interior crater wall located in eastern Hellas Planitia. The flow feature is approximately 1 kilometer wide and 5 kilometers long, with a partial double inner ridge and raised outer margin. The flow feature's surface is generally devoid of impact craters, and parts of its outer margin have deflected around obstacles. Similar flow features, though not as distinctively tongue-shaped as this one, are found in many other craters throughout the southern mid-latitudes of Mars. Recent studies of these flow features have determined a latitudinal dependence to which side of the crater interior these features are formed upon. For this particular flow feature, it has formed on the pole-facing slope. This polar or equatorial-facing preference has implications for the amount of solar isolation these slopes are receiving, which may be a result of recent climate change due to shifts from low to high obliquity. Although these Martian flow features may have Earth analogs, such as rock glaciers, uncertainty remains as to what types of fluvial, glacial, and mass-wasting processes are involved in their formation.